Students, welcome to my channel GS Maths. Today in my lecture from the chapter Indefinite Integrals, I am going to cover a few more types from this chapter. Now the very first type is integral. This is integral of x square plus 1 x to the power 4 lambda x square plus 1 dx, or it can be x square minus 1 x4 lambda x square plus 1 dx, where lambda belongs to real numbers, and 1 upon, or it can be only dx upon x4 lambda x square plus 1. Now the method to solve this kind of indefinite integral is divide the numerator. The method is divide the numerator and denominator by x square. Now what will happen if I take this case? So when I divide the numerator with x square, I get 1 plus 1 upon x square. I get x square lambda plus 1 upon x square. Now if I take this case, I get 1 minus 1 by x square lambda plus 1 upon x square dx. It will be like this. Now there is a plus sign in the numerator, so I will substitute x minus 1 upon x equals to t in this case. Why? Because the derivative of x is 1. 1 upon x derivative is negative 1 upon x square, so it becomes plus 1 upon x square. Dx is dt, right? So I want to get the value of x square plus 1 by x square also. So what I will do, I will square this. I get x square 1 upon x square minus 2 is t square, or it will give me x square plus 1 upon x square equals to t square plus 2. In this case there is a minus sign in the numerator, so therefore I will substitute x plus 1 by x equals to t. Why? Because if I differentiate this, I get 1 minus 1 upon x square dx is dt. So I will get the value of x square plus 1 by x square by squaring these. I get x square 1 by x square plus 2 equals to t square. That means it's t square minus of 2. Substitute the values in the numerator, that is 1 plus 1 by x square dx as dt, and x square plus 1 upon x square as t square plus 2. 1 minus 1 by x square is t square, minus that becomes 1 minus x square dx, this becomes dt, and x square plus 1 by x square is t square minus 2 in this case. The formulas applied will be dx, it will be x square minus a square, or it will be dx, it is x square plus a square. These two formulas will be applied in maximum cases, right? Again I repeat, if there is a plus sign in the numerator, the very first step is divide the numerator and denominator by x square. You get this form. If there is a plus sign in the numerator, put x minus 1 by x as t. Now if there is a negative sign in the numerator, then put x plus 1 by x equals to t and so on. You will get the required answer. Now I will explain this. It will be much more clear if I solve few questions from this type. Now the very first sum I would like to read from this type is, now many few types are left in this chapter. This is an important type from examination point of view, right? So it is I have to do few questions from this type so that you can understand it better. Now the very first question is, integrate x square plus 1 upon x4 plus 1 dx. Now divide numerator, the very first step, divide the numerator and the denominator by x here. I get this thing. Now there is a plus sign in the numerator. Put x minus 1 by x equals to t, so that dx is dt. Square these two sides to get this value. I get this. So just substitute the values. Dt, x square plus 1 by x square is t square plus 2. That becomes dt, it is t square plus under root 2 square. This is 1 over a tan inverse t by under root 2, where t was x minus 1 by x equals to t, plus c. Of course, constant of integration should be there. This is the way how we do this question. Now, second sum from this type. Question is integrate under root tan x dx. Now the sum seems to be a very short in length, but when you do it, you will realize it covers up a lot of space. Now the very first step is tan x equals to t. So tan x is t square. I have substituted under root of tan x as t. So tan x is t square. What is the derivative of tan x? It's a secant square x dx 2t dt, or dx is 2t upon secant square x dt. Now 2t, it is secant square x can be written as 1 plus tan square x. Tan square x dt. What is tan x? Tan x is t square. So this becomes 2t 1 plus t the power 4 dt. This is value of dx. Now just substitute. Under root tan x was t. What was dx? Dx was 2t 1 plus t4 dt. It becomes 2t square 1 plus t4 dt. Now it gets converted to the form t square plus 1 t square minus 1. What I have done, I have split 2t square as t square plus t square. I have added 1 and subtracted 1. I get 1 plus t the power 4 dt. Now t square plus 1, 1 plus t4 dt plus t square minus 1, 1 plus t4 dt. Both the forms will be covered. Divide numerator and denominator by t square. Divide numerator and denominator by t square. There is a plus sign, so put t minus 1 by t equals to u. There is a minus sign, put t minus 1 by t equals to v. In this case, solve. The procedure is same. Only thing was the substitution does matter, right? Now under root tan x I substituted t. I got the value of dx in terms of t as this. So I substituted it. I get 2t square upon 1 plus t4. 2t square was written as t square plus t square. Adding 1, subtracting 1. I get these two questions or these two parts. So this can be integrated using the same method which I did in the first question. Then this again with the same method which we discussed. This is the second question. Now, one more question from this type. Question is integrate under root tan x plus under root cot x dx. Now how you will integrate it? First write down cot x as 1 upon tan x, right? I can write this as negative 1 upon the reciprocal of tan x. Now tan x as it is 1 upon tan x dx. Take its LCM, tan x plus 1 under root tan x. Right? Now, again, substitute tan x as t. So tan x is t square secant square x dx 2t dt, or dx I got as 2t dt upon 1 plus tan square x, that is 1 plus t to the power 4. Now just substitute the values in this. This integral becomes tan x. Tan x is t square 1 plus t square upon its under root tan x. Under root tan x as t dx. Dx is written as 2t dt upon 1 plus t to the power 4. This cancels. 2 is taken out. 1 plus t square 1 plus t4 dt. This is again the form which we have discussed today. Divide the numerator and the denominator by t square. You get 1 upon t square plus 1, 1 upon t square plus t square. There is a plus sign in the numerator. After dividing, divide numerator and denominator by t square. Since there is a plus sign, this is the first step. Second step will be put t minus 1 by t equals to u, and then proceed as we did in the previous two questions. Right? This type is again a very important type. You just revise it, solve as many sums as you can from this type also. Now, today's next type, or next form of integrals is again a very good part of this chapter, a very important part of this chapter. Right? Next type is it is dx upon linear into under root linear. This is the next form. It is dx upon linear equation into under root of linear. For example, we will do a question and in this kind we put this under root linear equals to p. We substitute this. We put under root linear equals to p in this type. Right? Now it is integral dx upon linear into under root. For example, it can be of this form: dx upon its ax plus b, its under root of cx plus d. Now put this under root cx plus d, under root cx plus d equals to t, that is cx plus d equals to t square. Now find the value of dx. It is c dx, derivative of d is 0, is 2t dt, or dx is 2 upon ct dt. Just substitute the required values, right? And you get, from here I will get x equals to t square minus d upon c. This is value of x. Again I have to substitute here, so we will get the required answer. But it will be much more clear if I do a question from this type. Question is dx upon x minus 3 into under root of x plus 1. X minus 3 into under root of x plus 1. Now as told, under root of linear equals to t. That means under root of x plus 1 equals to t, or x plus 1 is t square, dx equals to 2t dt. From here, get the value of x as t square minus 1. Right? Now substitute here, I get dx. What is dx? Dx is 2t dt divided by x minus 3. X value is t square minus 1 minus 3, and under root x plus 1 was substituted as t. So the sum is solved. 2 dt, this t with t cancels, that is t square minus 4 dt upon t square minus 2 square. It is x square minus a square twice, that is 1 over 2a log of x minus a upon x plus a plus c, where t is equal to, where t was equal to under root x plus 1. This is the method how to solve the form dx upon linear into under root of linear. Put under root of linear equals to t, then square both sides to get the value of dx as well as x from that. Right? The substitute, then re-substitute here the value of dx and x. What I did the same thing. Right here, dx the value was 2t dt, I substituted. X the value was t square minus 1, I substituted. This was t, both the t get cancelled. Rest is your formulas if you remember. Right? Now, another type, the third type of today's lecture. It can be dx upon linear into under root of quadratic. Right? It can be quadratic into under root of linear. Now the type is yes, linear upon, that is next type, dx upon linear into under root of quadratic. Now in this case, what we are going to do, we are going to put this linear as 1 over t. Then find the value of dx, find value of x, substitute here to get the required answer. But it should be clear, it will be clear if I do a question for you. Now the question is dx upon, it is x plus 1 upon x square minus 1, x plus 1 within under root is x square minus 1. Now this is a linear, this is a quadratic under the root. What I have to do, put linear as 1 over t. Now I can write this as t raised to power minus 1. So dx equals to minus 1 t minus 2 dt, that is dx equals to minus 1 upon t square dt. Now substitute the value, but before that find value of x. X is 1 over t minus 1. Right? Now put this value in the given equation. What is value of dx? Minus 1 over t square dt. Okay. Then x plus 1 is 1 over t. X square minus 1, it is 1 minus t upon t. Thus substitute the value of x as 1 minus t upon t, its square minus 1. So what happens to this? It becomes minus 1 over t square dt upon, it's 1 by t. Now I take the LCM as t square, it is 1 plus t square minus 2t minus 1, minus t, sorry, minus t under the root. Now t comes out, it becomes integral negative 1 over t square dt upon 1 over t square, within under root it's now t square minus 3t plus 1. This and this cancels, it becomes negative dt upon under root of t square minus 3t plus 1. Just complete the squares. It's again the form which we have already done. Now negative dt upon under root of, it's t, half the coefficient of t, that is 9 by 4 added and 9 by 4 subtracted. 3 by 2 square plus 9 by 4 subtracted 4 minus 9, 5 minus under root 5 by 2. It's square. This will be there. Again the same formula, x square minus of a square, that is 1 over 2a log of x minus a upon x plus a plus c. This is the way how we solve the type dx upon linear into under root of quadratic. We put linear equals to 1 by t and then proceed as I have shown it to you. This is the method. Now the last type from this very chapter is quadratic into under root of quadratic, right? The last type of this chapter. Let me rub this off so that I can solve the last type. It's a very interesting type. You can do it. You can practice as many sums as you can, right? To clear the concepts and to know the types, how to solve each type of integrals. Now it is dx upon quadratic into under root of quadratic. Now in this case, we will put the variable equals to 1 by t. I will do a question. For example, is put x equals to 1 by t. If the variable is x, then put x equals to 1 by t, then do the needful. The very first sum. Question is dx upon x square plus 1. Right? It's a quadratic. It is a quadratic. Let me write it as, say, x square plus 2. Okay. This is a quadratic, this is also quadratic. Quadratic into under root quadratic. Put x equals to 1 by t. Now dx is minus 1 upon t square dt. That is minus 1 upon t square dt upon x 1 over t square plus 2. This is again 1 over t square plus 1. Solve it. It becomes integral minus 1 upon t square dt divided by 1 plus 2t square upon t square under root of 1 plus t square upon t square. Now with this t square goes, I am left with 1 by this. It is 1 plus 2t square under root of 1 plus t square upon t. This thing is left. Now minus dt, right? So t upon 1 plus 2t square under root of 1 plus t square dt. Now again it is, we will substitute, we will get, say, x square, x was this, and we got this as dx 1 over t. Let me do it once again. Okay, let me change this. It's not coming up. I will do this again. Right, let me write only x square. It's like this. Question is dx upon x square 1 plus x square. Right? Now put x equals to 1 by t. So dx equals to minus 1 over t square dt. Right? Now if I substitute the values, I get dx minus 1 over t square dt upon x square 1 over t square under root 1 plus 1 over t square. This and this goes, that is negative dt upon, it is t square plus 1 upon t. That comes out to be negative dt t upon t square plus 1. Now again a substitution is required. Put t square plus 1 equals to u, so that 2t dt is equal to du, or t dt equals to half du. Just put the value. I get negative t dt is half du upon, this is under root of u, that is minus half u to the power minus half du. Answer is minus half u minus half plus 1 minus half plus 1 plus c. Substitute the values where u was t square plus 1 and where t was 1 by x. Get the answer. This is the way how we solve this type. With this, all the types have been covered from this chapter, indefinite integrals, and in my next lecture I would like to do few more sums, few more questions which have come up in recent board exams for the previous years, right? Till then, revise all the lectures, go through all the lectures of this chapter, try to understand the types so that you don't waste any time. If the question comes up, it's sure, it's very clear to you, you are very sure that this is the type and this is the way how we are going to solve it. Thank you very much. Keep on revising. Stay healthy.